Hello friends, today we shall study a new chapter in second year organic chemistry. It is alcohols, phenols and ethers. In our previous sessions we have studied about haloalkanes and haloarenes. Today we shall study alcohols, phenols and ethers. All the three compounds, alcohols, phenols and ethers, they have one atom in common. It is oxygen. Alcohols have general formula ROH, phenols have general formula AROH and ethers have formula ROR. So all the three compounds have oxygen in them as common atom. For this reason, alcohols, phenols and ethers are also called as organic compounds which contain oxygen in them. They are oxygen containing organic compounds. Now, since all the three have different properties, we shall study them differently and not combinedly. Beginning with alcohols. Alcohols are organic compounds that are considered as derivatives of aliphatic hydrocarbons, similar to those of haloalkanes. They too were derivative of aliphatic hydrocarbons. Here, alcohols are also derivatives of hydrocarbons. But what derivatives? They are hydroxy derivatives. They are hydroxy derivatives of aliphatic hydrocarbons. This means they are obtained by replacing one or more hydrogen atoms of alkanes by hydroxyl groups. A hydroxyl group is OH group. This group is called hydroxyl group. So from any alkane you are replacing one hydrogen or more number of hydrogen atoms by hydroxyl groups. If you are replacing hydrogen atoms of alkanes by hydroxyl groups, then they are called as alcohols. They are called as alcohols. So today we shall study only alcohols. Alcohols are hydroxyl derivatives of saturated hydrocarbons. They are obtained by replacing one or more hydrogen atoms of alkanes by same number of hydroxyl groups. How are alcohols classified? Let us see their classification. Their classification is exactly similar to that of haloalkanes. The first classification is based on the number of hydroxyl groups they contain. Based on the number of hydroxyl groups they contain. If they contain only one hydroxyl group, then they are called monohydric alcohols. They are called monohydric alcohols. Like example, if this is an alkane, you replace one hydrogen atom by one hydroxyl group, then this becomes a monohydric alcohol. Mono, single, hydric, hydroxyl group, alcohol. Similarly, this example wherein only one hydroxyl groups are present, methanol, ethanol or methyl alcohol, ethyl alcohol, all these are monohydric alcohols. Then the second, dihydric alcohols. Dihydric alcohols are those in which two hydrogen atoms of alkanes are replaced by two hydroxyl groups. Example, CH3, CH2, CH, OH, here also OH. This could be one example, or else this could be one more example, and so on. If any compound contains two hydroxyl groups, then it is called dihydric alcohol. Third, trihydric alcohols. Trihydric alcohols are those in which 3 hydroxyl groups are present. Example, this compound, a very popular compound whose name is glycerol. Its name is glycerol. We also know this compound by the name glycerine, commonly used ingredient in soaps, which gives you softness. Then fourth is polyhydric alcohols. Now what could be polyhydric alcohols? Polyhydric alcohols are those which contain more than 3 hydroxyl groups. This trihydric alcohol like category was not present in haloalkanes. In haloalkanes you had only monohaloalkanes, dihaloalkanes and polyhaloalkanes. Here you have one more extra category, trihydric alcohols. Based on the number of hydroxyl groups they contain, alcohols are classified into 4 types. First type, monohydric alcohols which contain only 1 hydroxyl group in them. Then dihydric alcohols which contain 2 hydroxyl groups in them. Trihydric alcohols which contain 3 hydroxyl groups in them, and polyhydric alcohols which contain more than 4 hydroxyl group, which contain more than 3 hydroxyl groups in them. Now, if this part is clear, then monohydric alcohols are again classified. This is same as monohaloalkanes which were classified. Now monohydric alcohols are classified again based on nature of carbon atom to which hydroxyl group is attached. Only monohydric alcohols are classified based on the nature of carbon atom to which hydroxyl group is attached. Now, if the hydroxyl group is attached to a primary carbon, then we have primary alcohols. A primary alcohol is the one in which hydroxyl group is attached to primary carbon. Their general formula is RCH2OH. Commonly alcohols have general formula ROH, but primary alcohols are specifically indicated by general formula RCH2OH. Now in this example, OH, hydroxyl group, is attached to a carbon which is attached to only one alkyl group in the sense another carbon atom. So hydroxyl group is attached to a carbon which is attached to one carbon, then it is primary. Can this be an example of primary alcohol? Hydroxyl group is attached to a carbon which is attached to no other carbon. Yes, it can be a primary alcohol. So a primary alcohol is the one in which hydroxyl group is attached to a primary carbon. What is a primary carbon? A primary carbon is the one which is not attached to any other carbon, no other carbon, or else a primary carbon is the one which is attached to only one carbon. So can this be an example of primary alcohol? In this hydroxyl group is attached to a carbon which is attached to one carbon. Yes, it is a primary alcohol. This is a primary alcohol. This is general representation of a primary alcohol. Understood what a primary alcohol is? It is that alcohol in which hydroxyl group is attached to a primary carbon. That's all. What is a primary carbon? A primary carbon is the one which is attached to no other carbon or else attached to only one carbon. Then we have secondary alcohols. Secondary alcohols are those in which hydroxyl group is attached to a secondary carbon. What is a secondary carbon? A secondary carbon is the one in which the carbon is attached to 2 carbon atoms. See this example, here hydroxyl group is attached to this carbon. Now this carbon is attached on either sides by 2 carbons. So is this a secondary carbon? Yes, it is a secondary carbon. Understood? This carbon is primary, this is a primary, this is a secondary carbon. So secondary alcohols are those in which hydroxyl group is attached to a secondary carbon. A secondary carbon is the one which is attached to 2 carbons. Then we have tertiary alcohols. Tertiary alcohols are those in which hydroxyl group is attached to a tertiary carbon atom. What is a tertiary carbon atom? A tertiary carbon atom is the one in which the carbon is attached to 3 other carbon atoms, 3 other alkyl groups. Example, tertiary butyl alcohol. More famous example you will study in the coming classes. Here hydroxyl group is attached to this carbon and this carbon is attached to 3 alkyl groups, means 3 carbon atoms. Therefore, a tertiary carbon is the one which is attached to 3 carbon atoms. This much is the classification for only monohydric alcohols on the basis of nature of carbon atom to which hydroxyl group is attached. There are 3 classifications. One is primary alcohols, secondary alcohols and tertiary alcohols. Next set of classification is benzylic alcohols. Some books claim this classification as aromatic also. They also claim it as aromatic, but more appropriate will be benzylic alcohols only and not aromatic alcohols. So what are benzylic alcohols? You might have an idea what benzylic halides are. Benzylic alcohols are those in which hydroxyl group is attached to benzyl group. What is benzyl group? Benzene ring with a methylene group is called benzyl group. If it were only benzene ring, not CH2, then this part is called phenyl and not benzyl. Understood? Benzene becomes phenyl if one hydrogen is removed. Benzene with a methylene group, that is CH2 group, is called benzyl group. So benzylic alcohols are those in which hydroxyl group is attached to a benzyl group. What is a benzyl group? A benzyl group is a benzene ring with a CH2 group. In other words, you can define benzylic alcohols are those in which hydroxyl group is attached to a sp3 hybridized carbon. This carbon's nature is sp3 hybridization. Its hybridization is sp3. So hydroxyl group is attached to a sp3 hybridized carbon next to sp2 hybridized carbon belonging to benzene ring. So benzylic alcohols are those in which hydroxyl group is attached to sp3 hybridized carbon next to sp2 hybridized carbon of benzene ring. In very simple words, benzylic alcohols are those in which hydroxyl group is attached to single bonded carbon next to benzene ring. Hydroxyl group is attached to sp3 hybridized carbon next to sp2 hybridized carbon belonging to benzene ring. If not, hydroxyl group is attached to benzyl group. This is benzylic alcohol. Then third category we have allylic alcohols. This is also same as allylic halides only. So allylic alcohols are those in which notice this example and identify the hybridization of carbon atoms. This carbon atom, it is sp2, this is sp2, this is sp3. So how is this compound different from the previous compound, that is benzylic alcohol? See, hydroxyl group is attached to sp3 hybridized carbon next to sp2 hybridized carbon. This is also same as benzylic. The only difference is here you have a benzene ring. The sp2 hybridized carbon belongs to benzene ring, then it is benzylic. If hydroxyl group is attached to sp3 hybridized carbon next to a double bonded carbon, or else next to a sp2 hybridized carbon, then it is allylic alcohol. This group is called allyl group, CH2 double bond CH dash CH2. This group is called allyl group. So allylic alcohols are those in which hydroxyl group is attached to sp3 hybridized carbon next to double bonded carbon or next to sp2 hybridized carbon. Fourth type, it is called vinylic alcohols or simply vinyl alcohols. Here again, based on hybridization, we have this example. Notice here hydroxyl group is attached to a carbon whose hybridization is sp2. Its hybridization is sp2. So if hydroxyl group is attached to a sp2 hybridized carbon, then it is vinylic alcohol. This group is vinyl group, CH2 double bond CH. Vinylic alcohols sometimes are also called as enols. They are also called as enols, wherein en stands for double bond and ol stands for alcohol. They are called enols. Specifically vinylic alcohols, or if one carbon has got both double bond as well as OH attached to it, like in this example. See, this carbon has got double bond as well as OH attached to it. Then such examples are called enols. Remember that enols are somewhat unstable. They do not tend to stay in enolic form, but rather they stay in keto form. You will study about this enol and ketone form isomerism in the coming classes if possible. So what you should remember, that vinylic alcohols can also exist in ketone form. It is because a one carbon, single carbon, if it has got double bond as well as OH, it makes it unstable. For this reason it undergoes slight changes. We call that as isomerism. It undergoes isomerization to give you a different set of compound. We shall study that in the next class. But timing, what you should remember, that alcohols classification is done in 4 categories. The first category was based on number of hydroxyl groups. You had monohydric, dihydric, trihydric and polyhydric. Further, monohydric alcohols were classified based on the nature of carbon atom to which hydroxyl group is attached. You had 3 categories. They were primary alcohols, secondary alcohols and tertiary alcohols. Primary alcohols are those in which hydroxyl group is attached to a primary carbon. A primary carbon is that carbon which is not attached to any other carbon, or it is attached to only single carbon. Then we had secondary and tertiary alcohols on the same lines. Next we have benzylic alcohols. Benzylic alcohols are those in which hydroxyl group is attached to benzyl group. Hydroxyl group is attached to sp3 carbon next to sp2 hybridized carbon of a benzene ring, or else hydroxyl group is attached to sp3 carbon attached to aromatic system. Third category we had allylic alcohols, wherein hydroxyl group is attached to an allyl group. Hydroxyl group is attached to sp3 carbon next to sp2 hybridized carbon, or else hydroxyl group is attached to single bonded carbon next to double bonded carbon. Last category was vinylic alcohols, wherein hydroxyl group is attached to vinyl group, or hydroxyl group is attached to double bonded carbon. Now if this classification is clear, we shall study nomenclature of alcohols. We shall study now nomenclature of alcohols. To understand nomenclature of alcohols, you need to have some idea about nomenclature of organic compounds that you have studied in your first year organic chemistry. See, we have 2 systems of nomenclature. One is common naming system and the other is IUPAC naming system. In common naming system, alcohols are called as alcohols only, whereas in IUPAC system, they are considered as hydroxyl derivatives of alkanes or saturated hydrocarbons. For this reason, while writing the IUPAC name of alcohol, since they are derived from alkanes, you need to replace the last letter of alkane. The last letter of alkane is E. Therefore, in IUPAC system, while writing their names of alcohols, replace the last letter E by OL, by the last 2 letters of alcohol. I shall show you some examples. If this example is given, then this part remains as alcohol only, and this group is called methyl. So common name will be methyl alcohol, whereas its IUPAC name is derived from methane. You replaced one hydrogen by one hydroxyl group, so its name will become methane. I said the last letter of alkane should be removed by the last 2 letters of alcohol, then it becomes methanol. Similarly, you see this example, it is to be called based on this group as ethyl group, therefore ethyl alcohol, and IUPAC name it will become ethanol because it is a derivative of ethane. Similarly, this example, there are 3 carbon atoms and all of them are in a straight chain, therefore N propyl alcohol. N means normal or straight. IUPAC name, begin numbering. If the functional group contains carbon in it, that should be given first number. If not, then to whichever carbon the functional group is attached, that should be given first preference. So 3 carbons, prop, all are single bond, ane dash 1 dash all. Even if you do not indicate this number 1, it is fine. In this example, if I attach OH to the middle carbon, then this group is called isopropyl alcohol. It is called isopropyl alcohol. IUPAC naming system, it is done according to longest chain rule, then lowest number rule for alcohol, and if any other substituents are present, they are given suitable numbers. So for this example, you have 3 carbon atoms, so prop, all are single bond, so ane dash. Since OH is attached at second carbon, therefore 2 all. Do not forget to indicate number in these cases. If OH is attached at the corner carbons, even if you do not indicate their numbers, it is fine. But if it is attached to any carbon other than the terminal ones, other than the last ones, then you should compulsorily indicate their numbers. Then you have this example, this was for 3. Now let us see for 4 carbon atoms. Its name will be N-butyl alcohol, and IUPAC name, since it is 4 carbon chain, therefore butane 1-ol. Let us see this example. I attached OH to the second carbon instead of the first carbon. So this is, look at the nature of carbon to which hydroxyl group is attached. It is attached to a carbon which is attached to 2 carbons. Therefore it is secondary butyl alcohol, and IUPAC name according to lowest number rule 2 butanol or butane 2-ol. What about this example? You have again 4 carbons, but this is isobutyl group. It is isobutyl alcohol. For IUPAC name, again begin counting from the corner where hydroxyl group appears first. 1, 2, 3. 2-methyl propane 1-ol. All substituents are never to be treated as functional groups, so they should not be given more preference. 2-methyl propane 1-ol. How many examples are done? Fine. Next example is CH3CH3OH. In this case, this group is called tertiary group. Since it is of 4 carbons, therefore tertiary butyl alcohol. In IUPAC system, you are supposed to follow lowest number rule as well as longest chain rule. On that basis, longest chain rule means from here 2-methyl 2-alcohol. How do you name this? 2-methyl, 3 carbon chain, prop, all are single bond, ane, 2, all. 2-methyl propane 2-all is the IUPAC name of tertiary butyl alcohol. Some more specific examples like CH2, CH2, OH, OH. This compound contains 2 carbon atoms. It is an example of dihydric alcohol. If this much was there as a double bonded compound, then you would have called it as ethene. So it is called ethylene or ethene glycol. Ethylene glycol is common name, IUPAC name. While writing IUPAC name, begin numbering from the carbon to which OH group is attached. Since there are 2 carbons, it is eth, ane, 1,2 diol. Now you might ask me, sir, should I write E here or not? So always remember, if the functional group, if same functional group appears more than once, then while writing the name of primary suffix, E should be retained, it should be kept. If this was the case, I mean if there were 2 carbons and you had only one OH, then while writing you have ethanol. You will not write E here because functional group appeared only once. If it appears twice, then while writing the name of primary suffix, E should be compulsorily written. So ethane 1,2 diol is correct name. Then you have a trihydric alcohol example of glycerol or glycerine. So for this example, common name is glycerol. How do you write the IUPAC name? So if you count from here 1, 2, 3. 3 carbon chain, therefore prop. All are single bonds, so ane. Should I write E or not? Notice that there are hydroxyl groups which has appeared thrice. So E should be written dash 1, 2, 3 because all the 3 carbon atoms have 3 hydroxyl groups. Since it has appeared thrice, so tri all. Propane 1, 2, 3 triol. Then how do you name this compound? Numbering should be done according to rules which say that OH should get the least number and not double bond. So 1, 2. This is vinyl alcohol, common name. IUPAC name is eth dash 1 dash ene dash 1 dash all. Ethanol or simply eth 1 ene 1 all. Last example. This is allyl alcohol, common name, and IUPAC name how do you give? 1, 2, 3. So 3 carbons prop. Which ene? Notice that the double bond begins from second carbon, so prop 2 ene, but OH is at first carbon, therefore 1 dash all. This much was about nomenclature. There are much more examples to follow. You can follow them in the NCERT textbook. So today we have studied introductory part of alcohols, their classification and their nomenclature. In the coming classes we shall see their methods of preparation. Whose methods? Alcohols methods of preparation. That was all for this session. Thank you.